Computers store information using a specific number system. They don't use the base 10 or decimal number system that we use. And then I asked the question, what is the base number system? But I've kind of given it away in the email and in some discussions we've had leading up to now. You sort of see it on this animation, all the ones and zeros. You may have seen numbers like that, big long numbers that are bunches of ones and zeros. That's binary. That's the binary number system. And there are good reasons why computers use numbers that only include ones and zeros. When I used to work in the semiconductor industry, silicon wafers are, you've heard of Silicon Valley? Well, silicon, which is the primary material in sand, and it's used to make glass and mirrors, we would take silicon wafers, which look like a big round mirror when you first start with it, and then it goes through all of these elaborate systems and machines and equipment to layer on layers and layers of switches. It's just essentially a bunch of electrochemical switches. Because the only thing computers understand computers only understand two things: off and on. Off and on. There's either a switch on or a switch off. That's all. As smart as computers may seem, they're not smart, they're just fast. They just understand off and on. But anything that we understand, any value, any number can be represented with just off and on, with ones and zeros. And you'll see that as we learn binary together. The switches on these wafers that make up all of these little computer chips are not physical switches like you see here. They're electrochemical switches. So they're made up of chemicals and molecules arranged in a certain way where when electrical signals are sent, they're turned off and on. They're transistors. They're mini electrochemical switches, so that the size can be ridiculously small, almost to molecule size, and that's what lets computers operate so quickly. Before I show you this video, let's just talk about ones and zeros. I gave this example in the email I sent you of how 21 would be represented, but just to show you that what we mean by off and on, 0 is off, 1 is on, and you may see on some switches, like if you look around the house, you may see some switches that have these symbols on them, and you may have never realized that the 1 means on and the 0 means off. It's just showing you binary right on the switch itself. If you have a vacuum cleaner or something, it may have a switch like that. If you look on your Apple computer at the power button, you'll see this symbol. It's a 0 and a 1. It's off and on, telling you to turn the thing off and on by toggling that switch. This video that I'm going to show shows you some binary applications, or a very familiar binary application. But if you prefer to move on to the next slide rather than watch this, that's okay with me.
This is barcodes in one lesson. Barcodes are found on virtually all products that you see in any store. When a laser from a computer scans a barcode, it's actually scanning through a series of 95 evenly spaced columns and checking to see if each one of those columns is reflecting a lot of laser light or virtually none. Computers only understand ones and zeros, so any of the columns that reflect virtually no light are considered a 1. And any of the columns that reflect a lot of light are considered a 0. Probably the reverse of what you might expect. So in this example, the computer begins reading the columns from left to right. The first column reflects virtually no light, so it considers that a 1. The next column reflects a lot of light, so it considers that a 0. The third column is like the first. It reflects virtually no light, so it also considers that a 1. The fourth, fifth, and sixth columns all reflect a lot of light, so they are all considered zeros. The computer continues reading the columns all the way across the barcode and comes up with a number that is 95 digits long, full of ones and zeros.
So this base 10 decimal number that you see here, 5100001251, is represented in binary by a much longer number. And we're going to talk in this lesson about why it's so much longer. It has to do, well, actually, maybe I don't want to give that away yet.
These ones and zeros are then grouped into 15 different sections. 12 of these sections are used for the numbers that you see at the bottom of the barcode. The other 3 are used as guards. These guards let the computer know where the barcode begins and ends, and also where the 6 numbers on each side begin and end.